It's my pleasure to introduce Aniruddha Shahapure, COO at CyanConnode. Aniruddha Shahapure is a seasoned professional with over 30 years in the industry. Also, he is a certified cybersecurity expert. His credentials including being a chartered engineer, CI4 PTM certified, and a senior member of IEEE, alongside an MBA in finance. Shahapure has been recognized for his contribution with the VISHWAKARMA Award 2022 from Niti Aayog-CIDC. Before joining CyanConnode, he was the CKO at Pune Smart City Development Corporation Limited. His expertise spans IoT, IIoT solutions, AIML, and IT infrastructure, and he had played a key role in implementing significant projects in the industrial automation and IT sector globally. Mr. Shahapure will present a talk on cybersecurity in smart electricity. So let's welcome Mr. Shahapure.
The challenges. So one comes down to the hot topic of this world right now. It's cybersecurity. So I'm just pulling up the some of the things which Akirul Remanji and Gopal Krishnaji had said about. All the systems are going to be there on the IoT. The sensors are being locked, put up, and then you have seen the a smart grid architecture from Hitachi, which the things which we can actually get to an level of sensors and the IoT devices which can be connected to this the that is the physical rail can be connected to the cyber layer. So this is what the specific one which we think of critical infrastructure when we think of power. And CyanConnode is one of the leading narrowband radio frequency smart mesh network technology provider for the world. And then we have about installations more than 1.6 million meters across India, and 4 million to go more. Having said that, when we talk about the critical infrastructure, you see the system actually relies on the digital communication, where the transmitting data, the storage of data, the data residues, which plays role, and where we actually have this. You pull up all that data, and then you use this to you improvise the system. You have the proper control. So to understand the risk while we are putting up these critical infrastructure systems, we have to have a thorough assessment of the system, where the actual CIA traits, that is, the confidentiality, integrity, and availability of the data and system and the devices has to be taken care of. So cybersecurity in smart city, the smart electricity is like going to be a critical aspect, because the energy meter is the most last mile connected IoT device in the present world now. So we have about 250 million meters. So that is, it's a huge number. And then when we are going to connect all these things to the when on the internet, as an IoT devices and all, you're going to have the risks. So what kinds of risk which we can have is like, the highly granular data which is there, where the people's energy usage. So you can have a, a particular house consumption for a month, for a week of the day, for the week of the month, for the day of the week. So you can get to an granular data of that. And apart from that, it comes with all the data, where your Aadhaar card, your name, your address is been connected to that. So all these things are actually connected, and which can be hacked. So if you can hack, I can tell you the one example, that if someone hacks the system, you can actually pinpoint a particular house and then cut off the electricity for him. I will share you one of the example, where it's recently in 2018-19, I think one of the one of the casino is been hacked with a uh, although it is all connected, the cyber jamming and all, everything is there, but the sensor of the fish tank inside the inside that casino was connected to the as an IoT device to the Wi-Fi. So the hacker got into through that, and then he could actually get to the roller board, and then he could manipulate that. So you can imagine the kind of attacks which we can have, and then where we the system which right now it is there, so it can create a havoc. So what kinds of cyber attacks can happen? So we have this all the words which now everyone who uses email knows about it. The phishing. So and then you get malwares, then you get but then you can have the password attacks. So you can actually crack the passwords. So now the different kinds of levels of password protections are coming up. So denial of service, this is one of the attack where the you block the system, and then you actually cut down the availability of the system. Man in the middle, it's a conning. You con as in I'm the one who is going to provide and then do it. So SQL injection. So many this kind of attacks are already there, and then this can be created in a different way. There are the you can actually jump into the dustbin and then bring out and you can crack the passwords. You can actually con in the sense like you can pretend yourself as a service provider and then do it. So these are the things which are getting into it. And when we are talking about systems, connected systems and systems of systems, these are the ones which are going to have. So these are the some of the international use cases which we already know, and what has happened in 2015. The electrical power station in Ukraine suffered a cyber attack, and about 80,000 people were into dark. We don't know. We have never heard about that, not New York's thing, but it has never come out whether it could have been an attack. India, yes, the data is old. However, it's a COVID data at the COVID time. So more and more hackers were on the system. So we can check it out like 1.15 million people attacks or number spiked to 2020 from 4 lakhs. So these are the ones which are happening. We have got an attack on AIMS Delhi, then recent attack on utility and information technology infrastructure hit by cyber attack and ransomware. So there is another one ransomware which is specifically being solved in many smart cities also. So what you do, you actually get the data, you encrypt it, and keep it. So even though you have the data, you cannot use it. So that is what one of the attack is. Cyber attacks linked to the neighboring countries, like broke into the network of power grid in North India, including utilities. You see the why I'm putting up more pressure, more emphasis on critical infrastructure is power is the one where we are really dependent upon. So it's a next to water, air, and then it is power. And without power, it is very difficult for us to continue our day-to-day lives. And who is the weakest link into that? The human being. So human being is an element who is the weakest link in the cyber physical system. So how we can actually now being and me as a human, I can create. I will be vulnerable, forced to do the mistakes. Then the systems where I'm going to install the systems, I can make some mistakes. I can put up lesser security on it. So how the solution can comprise all of that. So not only the human, but then the systems which are going to work and connected to the devices, the one who is going to install the systems, those who are going to monitor the systems. I think Gopal Krishna ji specifically mentioned about the SCADA systems, where we can monitor each and every street light. Imagine if someone can get through to your operating system, to your command control center through a temperature sensor of a fish tank. Imagine street light, you can be there, and then you go into the system, you can put off all the street lights to an, you have seen those the movies, the fiction movies, that has come to a reality, that you're logging onto the system of the traffic, and then all the lights have been controlled. So maybe for the giving an ultimate to route to a robbery, you can actually create a green channel for them. So some of these things can be taken care if you have the one which we use. Basically, the CyanConnode actually works on giving the total solution, where our system is nearly unbreakable. So you can have the Swiss cheese model, where encryption, authentication, authorization, security audits, which when you're done, then malware protection is done, is been put. Then network security is been strengthened, and VPN security. These are the solution securities. If you put all those dots, then hackers can have a very minimal space to get in. Hackers are definitely, and I will tell you, hackers are all the time on 1 foot ahead from any of the technology, and these are the ones who are keeping us on the toes. So we have every alternate challenge is what we face. We keep on improving on the WAN security, infrastructure security. These are the security models which we keep on putting up. The application layer security, which the specific one, what I can explain to into in the next slide. I think I have very less time left for to explain all that. However, this is the end-to-end security control techniques, where you can see the whole total picture of meters, where the gateways are connected to the meters. The data is been taken from the meters to on a IPv6 tunnel. Then it is controlled to a cellular base station. Obviously, it goes through that, and then it comes to a public WAN, that is, or it's an internet cloud, and then it goes to the head-end systems and MDM. That is where the actual meter data is stored. It's kept. The billing has been happened and all. So you can actually have different level layered security, where smart meters can be have an encryption of AES 128 on IEEE 802.15.4. That is for the basically for the RF networks. Then we basically at CyanConnode, we have a unique certificate for each node. Each node is the H meter. So we have gone to an last mile connected device. So that is where we are going to put the security. And then there is a language which meter speaks. So we have the DLMS security. Then we come to a different layer, the another layer, where the all gateways which actually pass through, they collect the data from meter and then pass it through on the tunnel, into tunnel of uh, the uh, the connectivity provider, or it can be cellular, it can be any, I mean, the one who provides the connectivity. So it is a pass through. So we have a DTLS based security, APN, M2M, SIM without internet connection. So this is the security which been taken care of. Then it comes down to a public WAN, so where cloud and all. So again, public key infra SSL certificates, which we keep it in, a good eye on it, and we get those secured. And then where the data is being stored, while this data is moving, so this is taken care while the transmission is happening. So there are different methods which I have explained about how the data transmitted on the different stages, and here it is now, it is stored. So we have the audits done every time. We get the VAPT assessed, and according to that, the security is maintained. The requirement, according to the requirement of government, I mean regulations, and the specifications which we follow on that, so to get a end-to-end security. uh, this is the layer security, which more explanation on the terms of how we can actually have the different 5 layers of cyber security can be controlled. So each a layer, the physical layer, we have the the meters and gateways which are connected. The data link layer, we have this 802.15.4 on the MAC addresses. Then low power connectivity with the network, and then IPv6 network. Again, those are the ones which with AES 128 which we have. Then then UDP TLS also HR with the certificates and all, we actually care of. This is what I just wanted to take in platform to have something which comes out in terms of what next is coming. You see, the Swiss cheese model is there, the device security is there, the mesh radio network is there. These all working on unconventional computers. What right now is coming out is quantum computers, and quantum computing is much larger. It's not a large in the size, but it's massive in the calculations. So while when we are talking about AS128, that some of the quantum computer experts are coming out in news that the AES 256 also is it's breakable. So that security, which actually, if you say, I will just give you the example of comparison of the timing. So AES 128 with a conventional computer, if you have a key and asymmetric key, and then if you wanted to break it, you will have about maybe 400 years will take. It's nothing is unbreakable, but the calculations, then the time, that is what it takes a toll. This particular one can be with with quantum computing, can be done in 1 minute. So imagine 400 years of whatever the calculations which conventional computers can do, it can be done in 1 minute. Imagine what kind of beast is that, so which we are going to face. We are going to be ready for that also from CyanConnode, and we are looking forward those, and then strongly competing with that.
Thank you, Mr. Shahapure, for your excellent talk on cybersecurity in smart electricity.